हाँ, एक मिनट। हाँ, वो बंद करो। हाँ जी, फिर से खोलो। हाँ, क्या कहते हैं, कंप्यूटर ऑडियो वॉच। आप अपनी ऑडियो खोले। ऑडियो तो खुला हुआ है। अच्छा, एक मिनट।
Do a share screen. Hello, good morning, sir. Kamran, Avi, and Aruna. Hi. You guys can hear me? Asma, Faisal.
Yes.
Hello, good morning, sir.
Hi,
How are you?
good morning. How are you?
I am fine.
In my, I got the server access and it's working now.
Did you get
Hi,
new?
this is Faisal. Can you hear me?
Hello?
Hi, this is Faisal.
Kamran, did you get the server access?
Honestly, not.
Okay, send it. I forwarded you an email for the technical department.
Mm-hmm.
Send them an email that you need the server access right away because it's been a long time and you don't have a server access. I got the server access. There was a password I needed to connect to the database. So they called me this morning because I sent them email and left the message last night. So they called me this morning and they gave me the password so I can connect to the database now.
Hello.
So
Oh,
you,
actually,
mm-hmm,
uh,
Hello.
I spoke to them. What
yes,
they said was, yeah, hello.
mm-hmm,
Somebody saying hello. Yeah. And then they said right now they only give one credentials set. That is what you got is that one only. And then I asked for, one for each, all of us. One you should have it. Even one I should also have it to do some going forward in the project. Some of the things I do it and show it to you rather than doing while I was, giving the presentation because it takes so much of time in the project. They said they'll be giving probably tomorrow or sometime one for everybody. Until that, the one what you got only, you guys have to use it right now.
okay. So then when you to connect to the database, the password is Hannah at the rate of 123 with H in uppercase. I gave you the other details. I mean, I forward the email. But when you have to click to the database, when you click on that Hannah icon, it asks for the password. That password is Hannah at the rate of 123. H with H in uppercase. Capital H, A-N-A at the rate 123.
Okay. Okay. Just a minute. I have a.
Mm-hmm.
Good evening, Aruna. This is Anup. We are calling from Chicago. We exchanged information of Charlie.com as well as yesterday. I was trying to reach you, but we didn't get that time. Sometime later, if you have a time, please call me back again. Or we can talk tomorrow afternoon, whatever is convenient to you. Look forward to talking to you, and I hope you have a good rest of the week. Bye-bye.
Hello.
Hello, sir. Are you here?
Hi. Are we having a meeting today or no?
Yes, we are having the session today, yes.
Okay.
The thing is,
This is.
I was able to see the screen.
Yeah.
No, our instructor is doing something. He's trying to, I think he's checking to connect the server.
Oh, okay.
So,
Were you guys able to get your help from their help desk for the server?
Basically, I am getting this screen with the HANA
Cameron, your voice is breaking up. I can't hear you what you said.
Yeah, the audio from your mic is really bad, Kamran.
Yeah, I know.
Make a word out.
So for server, you have to send them an email, and they will.
I sent them an email to yesterday during the session, and they never replied back to me.
I sent them an email. I called them about the server. I have the server access, but I think they are not. Just give the one server access. If you give me your email address, I will forward it to you. You can use it, but they are gonna I'm gonna write my email address. If you email me, I will forward that email to you. Okay?
Okay, sure. Thanks, Aruna.
You're welcome. So this is my email address. Just send me a blank email and then I will forward that email to you.
Okay.
But
Yeah,
you said,
can you hear me now? I'm sorry. It was I had a problem disconnection and I connected again.
okay.
Okay. You can hear me? Yeah, okay. I have the other server access also right now, the same one yesterday I showed you. But all of you guys will be getting server access probably tomorrow or something because I asked them, you require it when I start the project. Like I said, even now also you require it anyway. So, yeah, probably you can also share the server access to Kamran, Alvi, and Pfizer and all that. I don't know, because they might want to test it for, let's say, a few hours in the next
Yeah.
1-2 days until they get their individual, credentials.
I don't have that Faisal's email and this Asma's email. Asma is going to send me an email and I will forward that email to her. And if Faisal can email me, I will forward that email to him also. He can try to connect to the server.
Who's speaking? Is that Veera?
Hello.
Yes, it's me, sir. It's me, sir. Yes. Hi, Faisal. Hi.
So what is your email address? Where can I send it to you?
Okay.
I posted in the chat box.
Right?
Sorry, yeah.
Hi Faisal, if you look at the chat box, I wrote my email address there. If you email me, just send me a blank email and I will email you the link to get the server access, okay?
Okay, great. Thank you.
Okay, you're welcome.
Okay, yeah, better Arna's email ID, yeah, that's right. Okay. Okay, so we were actually talking about attribute view yesterday. We just saw how to create a standard attribute view and time-based attribute view, and derived attribute view, and then copy from also. We have seen 4 options. That's what we only have, just 4 options to create attribute view. Attribute view is just a 2-dimensional modeling artifact. It is a very basic fundamental modeling artifact, the tiniest in our modeling artifacts that we do. And we do it with the help of master data tables mostly. We just take the master data tables and bring them together with the help of joins, and then that is your attribute. That's what we have seen yesterday. And let's just see today. Anything you want me to discuss about the attribute view yesterday, please?
No.
But I think, I think the Faisal and Asma is they have to go through that anyway. Yeah. And further, next to the attribute view, we have some of the topics. There's something called hierarchies we have inside the attribute view, by the way. This is something that we have to see. Yeah. Sorry.
Good morning, sir. How are you?
Yeah, I'm fine, sir. I'm fine. Come on, sir. I'll come back to your thing. I was busy, and I'm fine, sir. Sure.
No problem, sir.
I'll come back to you. I'm working on that. Yeah.
Yeah, sir. Sir, Mr. Faisal is my friend. So he just joined. So he have to compensate the past lecture, and please help him out.
Okay. So in that case, probably I will take some a couple of hours in the evening for him. Yeah, some other time. You just text me. I'll let you know, sir. I'll take a couple of hours for him. Sure.
Thank you.
Yes, sir. You're welcome. So yesterday when we were developing this attribute views, we have seen that only 2 nodes we will have in the attribute view all the time, just to data foundation and semantics. The data foundation is the node where we actually drop all the master data tables into this, just by dragging and dropping here, or we can also do by clicking this plus anyway. Either way, we have seen all this. And one more thing that we have not seen is in the semantics, you have something called hierarchies. Yes, this is something that we have discussed right now. This hierarchies topic, we have to talk about it. Let's see what is hierarchies. So hierarchies basically 2 types of hierarchies we have. We usually use these hierarchies in the reporting technologies. When we report from this object, what happens is we try to traverse through the hierarchy, be it level hierarchy or parent-child hierarchy, as we have 2 types. What happens is when we are at the child node, we can just go up to the parent node, or when we are at the one level, we can just further go up or down based on the level that you are at. So it will help us to traverse through the levels or parent childs, the hierarchy types, while we are actually using this object in the reporting technologies, because the ultimate purpose of this modeling artifacts creation is going to be the consumption side. The reporting technologies are going to be used to consume these modeling artifacts in order to fulfill our requirement. So at that time, these hierarchies will be helpful, obviously, the same way that the modeling process is helping us, right, to break down our requirement into several aspects, and each aspect is going to be different modeling artifacts, and we combine. That is what is going to be the whole requirement. So that way, these hierarchies, let's see these hierarchies. So we have two types of hierarchies. One is parent-child, and the other one is level hierarchies. So it looks like this. Hope you guys can see my screen. You guys can see my screen, right?
Yes. Actually, it's better now.
It's better because I think it's an internet problem. I tried to change my ISP, and I know now it is better.
Okay.
So actually, the fundamental difference between these hierarchies would be, let us first talk about the parent-child hierarchy. In the parent-child hierarchy, you have the nodes are like this. You have a parent node, and following you have a child to that parent, and then the child becomes again a parent because it will also have a child, so on and so forth. Usually, the parent-child hierarchy requires two columns to put it in the modeling. So the one column says the parent, all the parents will come here, and the other column says the child, so all the childs will come here. Of course, the parent can be child also. The two is a parent here at the same time. It is a child as well. So this is how it is done, and these two can be a distinct fields. And if you look at the level hierarchy, it is a little bit different. So level hierarchy, let's say we have DAC countries, and then inside the DAC countries we have Germany and other countries also. Inside the Germany you have the cities called Bayern and Hamburg. So here this is like a level. This level you have a DAC, and this level you have a countries, and then the next level you have cities, so on and so forth. So here what happens is the level hierarchy, the number of columns are going to be the number of levels that you have. You have 5 levels, you have 5 columns in the modeling artifacts that you define. The same way here, the difference between these two would be this one will have the same. This one will have the same data type, the level hierarchy. I'm sorry, the parent hierarchy, the level hierarchy, possibly the different data types. This region and then country and the state could be different data types. But here, since parent-child can be the same node, the parent and the child is of the same data type here. But here is different. That's how you differentiate between parent-child and level hierarchy. Here only just 2. Here you have 3. And then that's it. These are the 2 types. For example, if you have a country and then city and then country, region, city, street, that could be a level hierarchy. Things like that. Let's just see some of the hierarchies that probably I defined.
Sorry, when you say
so here,
when you say
please.
What do you mean by same data type in the previous picture?
Okay. Here, when I say the same data type means, see, I'm talking about how we implement these hierarchies, right?
Right.
When we implement the level hierarchies, we have to set the number of columns based on the number of levels that we have, and then this column is going to be a it is defined inside the in your modeling artifact as an attribute, right? So it'll have to be with the data type associated with it. For example, it's a string or integer or anything. You have a double and all that. So that particular data type is going to be a same for all.
Okay.
You got it, sir?
Yeah.
Yeah. Here, yeah, that is the difference actually. That is the difference here.
So in the attribute view, do you set all of these different data types? Or how do you set the hierarchy in there?
No, it's based on the levels. See, I'm sorry, two ways I should talk about here. Here, the level is different data types, and the parent child is the same data type. Okay, if these two columns are based on the node, we set the hierarchy. I'm going to show you actually this, just explaining the theory. The practical I'm going to show you just about now. If it is a parent child, the parent can be a child. So these two, mostly the data type is the same data type. This and this all are the same data type. But you have the two columns to represent one for the parents and the other for the child. But here, different data types, one each for each node will have one level. So number of levels here equal to the number of columns that you have under the modeling artifact. So that way, I mean, you will actually see while I implement, right? While I show the the example, for example, right now. Yeah.
Okay. Yeah.
Here you have to click the hierarchy like this. It'll have the name and label. You see the label hierarchy or the parent-child hierarchy. For example, I have developed this hierarchy for you. How we do is, first of all, okay, the name. You have to give the name. Label is just an option, just to explain what is description. And I'm giving the label hierarchy in this example. It's just frozen here. So label hierarchy, how do you do is, you just have to click here and you just have to choose what column is going to be your label. Because here, every level we represent, for example, land one here. You have idea with the tables of KNA1, MARA, and all these, the SAP tables. First of all, let me ask you. You guys have idea with the SAP tables such as MARA, used before, KNA1, T005U, T005T, and all this. Any idea? I hope you used in your, while you're working the SAP system before, right?
I have no experience
Why so?
with that.
No, actually, no. No.
These are the tables. I believe these tables are maintained by the developers. The consultant they don't do anything with these tables. The developers don't give the privilege to you to use these tables. I mean, they can, consultant can use that, but they cannot do anything in those tables.
Sorry, I have unmuted. Is it? You're not? For how long this is unmuted? I will just keep on talking.
When
Sorry.
you ask, do you know anything about these tables? That time, after that, you got muted. So.
Oh, wow. Okay.
Tables, actually, I know these tables. One is for tax, T005U, but as a consultant, I have never used those tables because developers are the one who maintain all those tables. So
Yeah. Okay. No, that's okay. See, any time when we are actually, learning HANA, so we got to deal with the tables, right? It is better when we deal with SAP ECC tables, That's the only, that's the only intention. So rather than I have also other tables to show you. But we may not be having very good tables from us because we have to make some tables like protect the customer. There has to be a meaningful, connection between tables and meaningful data inside it, right? So we try to use SAP ECC tables. That's what I want to say. In fact, in our COPA exercise, it's going to be completely SAP CO.
yeah.
I said from this we take all these tables. In fact, the tables right now that I'm showing you is SAP CO. In particular, the submodule is called COPA. Inside it, the CO is the main module, and the submodule is called COPA. So anyway, so this example has that, but don't worry about the logic and content for the moment. You just see the how the hierarchies works. Because the logic and content I'm going to show you in the project that we do. So right now I'm talking about here. How do you do the level hierarchy, for example? So the level hierarchy could be, you choose the level hierarchy, and then you have to say, for example, in here we have country, region, and then city. Land 1 is a country here. Land 1, the country column name here is on the SAP standard table. It is a land 1, and the region is column name is a regio. You have to choose that. You have to emphasize in here saying that these are the levels. Please follow it. So we're actually telling the system. So these hierarchies are not available in every logic. It depends on the data content you have, the tables that you have. It may be available. You have to check it out. If it is available, you take an advantage by just making a hierarchy. It is just taking advantage at the report timing. But of course, it is not necessary that every table that you deal will have a hierarchy, isn't it? And then you can also do the ordered by, the same meaning, which direction you want to order. You can also say the sort direction also if you want ascending or descending. So that's it. Your level hierarchy works like this. And then your parent child also works the same way. with the example. I do not have example right now here, but it works the same way. You choose the parent child here. So here you got to add the parent node, and then you got to choose the parent node, and then you got to choose also the child node. Just two here. So that way it works. And if you go to the advanced inside this, you know, you can also say aggregation. By default, it is aggregate. See, there's something called orphan node. Orphan node means when we do the like this. Sometimes there is a in this process we don't know this is actually the child is belongs to one particular parent, or you know, it can be from two parents. So that time we just treat it as an orphan node. That is also, I require some nice example to explain to you. So and then it will have a multiple parent at that time. If you have if the child is from the multiple parent, you just choose this. So all these are the settings that you will have to do. But the good thing is, these hierarchies can only be worked in the multidimensional reporting structures. If you have a relational connection, for example, here when we deal with the you know, all these modeling artifacts going forward, we will be having, you know, reporting technologies and then connecting to our modeling artifacts here. So SAP HANA box, we connect with the business objects, for example, modeling business objects reporting tools, and also some of them could be MS Excel. This is also Microsoft business object analysis for Office, they call it. Office is also embedded with the business objects. So we require you know, multi-dimensional connection here to see the hierarchies, MDX connection. MDX and then SQL, I think we discussed two things. SQL for the standard relational connection, which is you know, two-dimensional objects you can access, but MDX is for the multi-dimensional expressions, which is connection for the to access multi-dimensional objects. So MDX is a multi-dimensional expressions long ways. If people or some of the people also learn this, I do not know this MDX, but if any of you could also learn this, like SQL, this is also different long ways. But SQL is enough for us at the moment, because underlying communication is going to be in MDX or SQL, and we don't have to bother about it. But we have to know that based on the tool, what kind of long ways it communicates with the SAP HANA. We have to know that, so that we understand how the technology works. So going forward, we will only see about a little bit about SQL script, and we will not talk about MDX. But MDX is something that you have to know, multi-dimensional expressions. Yeah, if any of you have interest, you can also learn this. This is a special language to deal with the multi-dimensional objects anyway. Question is, can't we talk with the multi-dimensional objects with the SQL? We can also talk actually. That's what is happening. You heard this rollup. I think you guys know this rollup. You heard? Any idea what is rollup? First of all, what is OLAP? And the next question would be rollup. It's the same thing actually.
OLAP is the online analytical processing.
Yeah, right. And then rollup?
Rollup.
Yeah, okay. I will just yeah. It's actually, you have rollup and then R OLAP and then M OLAP, H OLAP. There are actually two, three types we have. The idea is like this actually. Why I'm saying is, HANA is rollup here, not multidimensional OLAP. Exactly, relational OLAP, multidimensional OLAP, and this is a combination of both. H OLAP is. So relational OLAP, what is it? Any idea?
Relational.
Let me go back. Yeah. See, we are seeing this. We have seen, a little bit theoretically about how the complex multidimensional objects looks like, isn't it? Like this, for example, what you're seeing on the screen. There could be a complex multidimensional object which is there, but how do you represent inside the, logically or inside the structure? How do you represent this particular object, which is a use and which is complex, which has several dimensions? We can also represent the whole thing can be inside one table itself, right? For example, here, the example that I showed you, this example, if you look at this example has, right now here, more than 2 dimensions. It is, for example, product is 1 dimension and storage 1 dimension. It could be sale ID also, sale could be. My point is, even the multi-dimensional object can be put inside the table, just a simple table, isn't it? This looks like a left side, it looks like a simple table, like this example is. I think I should show you this one. This one, left side, it looks like a simple table, but the, visualization, the right side is something that we can imagine, imagination. The right side is something that imagination, which means it has a depth. So the whole thing, the whole multidimensional, we are just putting in a relation. Relation is here, nothing but a table. But actually, there are other ways also. There are other structures in the market. It is not necessarily that the multidimensional structure should be in the relational table. So that is called multidimensional OLAP, MOLAP. But right now, we only deal with ROLAP, which is relational. So any number of levels you have, any number of dimensions you have, maybe we may not be able to imagine here the right side imagination if it is more than 3 dimensions, because it is very tough for us. But we can accommodate the whole thing inside the table, isn't it? You agree with me? See, it's actually the simple table is this, right? The first example I gave you was this one. Let's say the product is a simple table. This one is a simple table, for example. But if you go into the cube, the middle one, what happens is it has a depth like this, isn't it? It has here depth of 2 dimensions. Here in this example, 3 dimensions. So on and so forth. In the next example, it could be, I could put 4 dimensions. But 4 dimensions, left side table, the fact table view is there. And then this right side is an imagination for us to understand, isn't it? The depth of it. Correct, right? You got, I don't know what I'm trying to say. See, what I'm trying to say is the whole multi-dimensional cube can be put inside just a normal table. If you look at this, maybe you wouldn't know that it is a complex multi-dimensional table unless you look into all the aspects and understand it. For looking like it just looks like a table, that means the whole OLAP putting in the relation ROLAP. So that is what it is. We deal with the ROLAP here. There are some technologies that deal with the MOLAP. The whole thing they put it in the multi-dimensional structure itself rather than putting in the relation. So here RDBMS is a simple thing actually. You know that, but the realization, you all know that, it's just realization. Imagine if I have 5 dimensions here, how can you put the picture here? It is difficult, isn't it? So we just have to imagine, yes. So maybe 3 dimensions, 4 dimensions, we can put it here. But it has a depth. The depth is the number of dimensions, the levels. So that way, what I'm trying to say here is, all we talk about ROLAP here. So that way, SQL is enough for us to communicate with the multidimensional objects, right? Now you are convinced, isn't it? We don't need multidimensional expressions, isn't it? But at the same time, you also have multidimensional expressions to deal with the multidimensional objects. You can learn, if somebody is interested, they can learn this language, multidimensional expressions, MDS. But right now, SQL only we deal with. There are some technologies such as MS Excel talks to the SAP HANA using MDX, not SQL internally. Some of the viewer reporting tools talks to the SAP HANA using SQL. See, there is also a hidden language that they talk, right? But even though we use the tool with the GUI based equipment, but at the same time we have to understand what are the facilities we have. I hope you got what I'm trying to say, okay?
Yes.
Okay. So, and then we move to from the hierarchies. So you don't worry about the hierarchies. I'll show you in the COPA project, but obviously you have to know the concept. I hope you got the concept. How do we create the hierarchies? And then I will move on to the next topic, which is called, okay. Yesterday we have seen a little bit about the time dimension. Actually, how you can control the time dimension is, let me just show you an example here. See, there's something called generate time here. We'll be talking about all this, all this in a quick view. Maybe in one class we'll talk about this. This will take more time. But let me just quickly show this generate time data. It's something that you can actually see. I discussed that there is a, there is a time dimension available here in the system table, right? Yesterday, for example, you can just go here and show here. Just a minute, I'll show you the time dimension here. And this is the one actually. This is the one. In this you have day and then week, month, year. This is system defined time dimension. Here you have, you see all this. See, first of all, why we require that? Most of the programming languages or technologies, database type of technologies, we have the system defined time dimensions or the time attributes. Why we have the system defined time attributes? Because it's like this. For example, your project is dealing with the time. Let's say time is let's say you have date. For example, if I just put it, the date is like this. Let's say one of your column has this one. When you deal with the reporting, I ask, it's okay, what date it is in my question, in my requirement, okay, I can fetch this. But if I ask, what is the weekday of it? So I have to find an SQL query, right, to find out which this date is falling on which week. And then I say, which week of the year? So we have 56 weeks, right? And then I say, which quarter of the year? And then I say, there are so many questions we can ask just by looking at this date, isn't it? The questions while we deal with the reporting structure, what we do is we have to compose SQL query. On the other hand, the best way is while doing in the modeling itself, system has developed a standard time dimension. If you give this to the system like this here, by just looking at the day, you can find out week, year, day of the week, day, hours. For example, this particular date does not have the hours details. For example, in some columns in your project, you might be having the hour details also. So here, the system-defined time dimension. This is, I'm talking about the system-defined table. This one I did not, but nobody done it. SAP has done it here. This is from the system schema, SIS_PI is a system schema, system-defined schema. Inside that, these are the system-defined tables. So we're just trying to learn how they work for us. So you have more details of that particular time. You have like what quarter it is, what week it is, what year it is. Otherwise, what happens is you have to work on this to find out what it is. You can work on it, but it is a little bit of more work for you in terms of writing query or doing something, Rather, if the system can give a facility like this, you can just, bring your actual, table and near to this time dimension table. Let's say this is the time dimension table, and your system table is this one where it has one of the column is a time, which means could be the date or any of the time related attribute, let's say this column. And then what happens is you can bring these two together with a join, where if you use the inner join or other combination of joins, you can capture, by looking at this date, you can capture all the dimensions of the time, right? You agree with me? For example, the dimensions such as the week of the year, and then the quarter of the year, then the month of the year, and which weekday it is, which week of the year, everything. All these are available here. So by doing this, you will be able to access the other dimensions of the time. As long as you match this, obviously you will be matching this, because this particular data type is mostly, we have a couple of data types, so all the data types are available here to find a match. So what happens is when you do this together and then get the common elements, the immediate question is, let's say my project, I'm dealing with the time from, let's say, 2010 until 2016. Let's say my project is dealing with this. Now how can you control the system defined time here? Yes, you can control. For that only I'm saying you have to go here. That is where you control. So that is where you control your exact time in terms of years, months, and days. So if you control this, that means your system defined time makes it stable such a way that the data is in between this. Because we have options here. We have options for the days, months, weeks, days, weeks, months, and years. We have for options. Inside the days, we also have for the seconds, minutes, hours also we have inside this. So what happens is here we have the date SQL format you have, and then date timestamp there is one, and then SAP standard type there is one. All these are the data types, which takes the date from the system. At the same time, when you bring your table together with this, you make sure that one of this data type is your system, your table data type, so that when you join them together, you can capture all of this. The idea is to capture any of the dimension, such as the week of the day, the quarter of the year, and the month of the year, and all these things. You understand? So that way, how do you control here the actual duration that you're looking at? The project, your project could be going for 3 years, 5 years, 20 years, the gap. That will be set here. How you set is, I'll just show you shortly. You just go here, and then it'll say you're following your project wants Gregorian or the fiscal. Mostly fiscal is for the financial institutions. They will have their own financial years. So this is the fiscal year it'll follow, and Gregorian is the standard the year calendar that we have right now from January to December. That is a Gregorian. This is the one that we use quite often. And then here you say, yes, my project follows, let's say 2010 up to, let's say, 2016. Let's say this is the boundary that I'm looking. And then you say, I want granular of, month, week, all this. Imagine, do not put second and so many years, because for every second, for that many number of years, you have one record for every second. So imagine in one day itself, we have 16 to 24 records in just one day. So it cannot, the data is huge if you put second, unless your project deals with, obviously, this is based on your requirement on your project. Let's say we put it week or day. So if it is a day, so you will have that many number of days, that many records. So which means every year 365 records you will have if it is a day. If it is a week, let's say every year we will have 56 records, So based on that, and then if you say the week, you have to set the first day of the week. Again, we have possibilities here. In some countries, it's going to be Monday, some countries Sunday. So this is like this. And then we finish this. What happens is the system defined tables, the data is changed now accordingly. You see, now if I open this, if I go to the distinct values, for example, this analysis, so if I say years right now here, So it is actually, it has, I think we have taken the weak one. Yeah, this is the one we have to see. The weak granularity, right? Just now we have taken. Yeah, this is the one we have to see. Yeah, you see, it has 2010, 11, 12, 13, 14, 15, 16. It has the boundaries that we set. So you can set that. This is just a structure, and then there's a default value is there, but you can set here your boundaries by looking at generate time data. Once you set it, that means this table has the required, the time data that you want. But the only thing that you have to do is you have to bring this table, you have to make this table as an attribute that we have seen yesterday. How do you make this one as an attribute? Of course, when you derive this attribute views, you just have to, choose it as a time attribute. For example, like this, that we have seen yesterday. This one is time. That means that's it. You are bringing the whole object into attribute. What is an attribute view? It is just a view for you to work in your modeling. It's a basic fundamental view for you to work on the multi-dimensional views going forward, in which this fundamental view is going to be used as a dimension. So that is how we do it. Is it okay? Any questions on this? Hello, Aruna, is it okay?
Yeah, I think it's okay. I don't have any question right now.
Yeah, because it might look a little bit, complex at the moment for some people, but it is not really complex. Probably I will also show you, in our project scenario, probably I'll have a time dimension too. But if not, it is just, I think in every technology you have the system-defined time. So here they call it as a time dimension because we just use this as a dimension, which is like a two-dimensional artifact. We just bring this one as along with the master data tables, and then plug in this dimension while we work with the multi-dimensional artifacts, just to get to that, the type of the time that I discussed, like week of the year, quarter of the year, month of the year, and then weekday of the, date, and things like that. Without difficulty, we can just get to the required column and just present it in the reporting system technologies, okay? And for this, you require, so there are certain requirement we have. Yesterday we discussed M underscore these tables for the Gregorian. You require to understand and remember these four tables: M underscore time underscore dimension underscore month, week, and year. These are the four tables, system-defined tables. And for the fiscal, you have T009 and T009B also for the fiscal. So this is a requirement. And before we go on to the further dimensional artifacts, right now we are actually learning modeling artifacts. We just only learn the simple modeling artifact, which is attribute view. Before I move on to the analytical view, it is better that we try to learn a little bit about the schemas, because just now I was talking about the system-defined schemas, and then we have to understand what are those, Just now I said SYS underscore BI is a system-defined schema. Then immediate question would be, what are the other system-defined schemas that we need to know? And then what are the types of the schemas itself? All these fundamental questions might come into your mind. For that, it is better we try to first see all the types of schemas and then move on to the next multidimensional modeling artifact, which is an analytical view. Right now, we have just 3 types of schemas here in the whole schema structure. I hope you remember what is schema we discussed. This particular symbol you see is for the schema. So the schema, let me just unfilter this. So you can actually filter with the schema name so that it will only just show those schemas, because you don't want to look at all the schemas and choose and get lost in this process because you have so many schemas. Normally what you do is you try to create like your own schema. You try to say create schema, your own name or something which makes sense here, and then that particular schema is available here. You can just filter this. So these are the schemas. So now immediate question is, how many types of schemas that I have? 3 types. Either system defines its schema, or you define your schema, or SLT derives. What is SLT? SLT is nothing but SAP landscape transformation, which is this. This is actually a data replication technique. We still have not covered this topic. We have some topic called data migration or data replication also. So that is data migration we have, right? And the data replication. I still have to cover this topic. This is a very important topic. In this, we try to learn about some of the techniques called business objects, data services, SAP landscape transformation, smart data access could be, if we have time, direct extract connection, things like that. All these are the technologies rather, methodologies for us to bring data from, let's say, from one box to, which is a source, to HANA box. Basically, the target has always been HANA here. So SAP HANA. The source could be, it could be a SAP source or non-SAP source, or anything, some Excel file or some application, With this, we try to do this. In that, we have something called SAP landscape transformation. Why I'm talking this is, that particular SAP landscape transformation process also creates a schema. There could be only 3 types of schemas here we have, in the whole HANA. So either you define it, or the system define it, or SLT define it. That's all. So now let us see what each. We define it like, basically, we have a privilege from the database administrator to create a schema. That is why yesterday I created a schema for the Aruna, name of the create schema Aruna, or create schema Asma, for example. Right now, if I create it, yeah, I'll show you. This is because I have a privilege to create this. Let's say if I say this, then if I say, please take this command, which means it is positive. There is no red here, means which is positive, which means there is a schema called ASMA1, which means you're able to create it. That is user creating schema. I can get to the schema right now, just pressing A, and then I'll see the schema. Okay, I showed you. This one, yes. This is an empty schema right now. There are no tables, nothing, but it has all the structures in place because, the moment you create a schema, what is a schema, first of all? I think we understand schema is nothing but like, it is a database. It is a mini database. It qualifies all the rules that the database does. It has all the database artifacts, the physical artifacts, such as tables, views, stored procedures, and all that. It is like a container of all your, database objects that you may have. For that, you try to first create your container, keep it ready, and inside your container, you would be creating, all your physical objects, such as tables, stored procedures, and everything. So that is how we create user-defined schema does it. And then SLT derived schema is something that I spoke to you just now, this one. In the process, we have to go through this process. I still did not cover this topic. SAP landscape transformation technique, this one. This one will have a separate server component. So it is like this for you to put, in a nutshell. You have this SLT server. And you have this as a source. And then you have the target also. This one is could be your SAP system or your non-SAP system also. It could be anything. And then this one is always HANA as a target. And then I have to show you this. I have to show all the configuration settings, that what are the configuration settings that we need to do in SLT, how we can get into this SLT first. This topic is not covered. We're going to show this. But the process of end of this process, you end up having schemas here which are created. The SLT creates schemas to bring the data. SLT is a replication technique, which is a real time. So which means it brings the data one time from here to here. And then the next time, if any changes here, the changes also will come here. That is what we call this as a replication. So it is real time with a latency 5 seconds, 1 hour, half an hour, or anything that you said. So this technique also creates a schema while you do it. We will see that anyway, but just for you to learn right now.
Vera, quick question for you. When you mean by SLT replication, does that mean like something like a CDC where some changes happening on maybe the target table and then it's coming over onto your HANA tables later? Or is it like data warehouse sort of a thing where it's taking it from some other schema and then bringing the changes over into your HANA database?
Okay, let me just tell you, yeah. It is like we have this can be called as a ETL, but it's not good to call, or data provisioning technique, actually. The best name to call is data replication technique, actually. But this is the best name is data replication, because I'll tell you. This is the best name for that. What we do is basically, like Asma is asking right now, so we have tables here in the SAP system and non-SAP systems, okay? Obviously, these tables are sitting at the database, like she said. Obviously, these tables can be sitting at the database or could be data warehouse. See, what is a data warehouse? Data warehouse also will have a database, right? There cannot be any data warehouse without database. The underlying database is always database. The structures, the structuring of the data that you do makes it fall into a data warehouse, isn't it? So I'm not getting into that. So basically, here you have a database.
I'm sorry.
And then the database is associated with your SAP system or non-SAP system. So your idea is how I can bring these tables into my HANA. So for that, we have several techniques here. And then SLT, what we do is, just now Asma is asking, let's say I want to bring this table, Mara, sum table, yeah. Right now, this table has, let's say, 200 records, yeah. Once I use this technique, what happens is the whole Mara comes here the first time. Now in my process, let's say this is my OLTP system. Okay, it is possible that this could be my OLTP system, right? So what happens is in the process of, in my business, I'm getting Mara records, some more records also getting piled up. Let's say now my Mara has become, 205 records. So what happens is those 5 records are the delta, we call it here. So that thing will get affected here also. So we have to do all the configurations and settings in SLT, how to handle that, upcoming records here, because this works real time. Remember, SLT is real time. You can also set such a way that this records you see whenever you come, it comes here within no time, within 5 seconds, 20 seconds, you can see the data here also. So that process is SLT server configuration settings that we have to do. It is all about, how you can do the process, what kind of connection you use this, what kind of connection you use this side, how you can tap, or how this technology works. That is a separate topic that I'll have to cover. Is that okay now, Asma?
Yeah, that makes sense.
Yeah. Yes. Fine. And right now, I said, okay, now I should go back to your slides right now here. Yes. So that's why here, why we are trying to know a little bit about SLT is because SLT process ends with creating a schema also. So it is also creates a schema for you. So the other one is a system-defined schema. What is a system-defined schema? First of all, the schemas are, these schemas are delivered with the SAP HANA box with the database itself when you install it. In the HANA system, you have these schemas, like always the system defined schemas are sys_sys. It starts with _sys, always. This is the tag here to remember, since it is a system defined schema, followed by different types you have. BIC you have, BI you have, repo you have, statistics you have some other system defined schemas. Only a couple of them you need to know. You don't need to know all of them. I mean, you can just take the HANA manual and you can look into that anyway. But I'll try to explain you a couple of them actually, which are very important for you to know the system defined schemas, how they work. See, the sys_bic is one of the system defined schema which contains all the column views of activated objects. What does it mean? Anybody can explain to me here? I don't know. Because this is something that you have to know, very important. See, I'll just explain. In the modeling, what we do is we do like create and then save and then activate, obviously preview or use it. These are the 4 stages that we have in the when we create modeling artifacts. So what happens at this stage? Activate means, I've already discussed with you. You remember, sir, Kamran? I don't know what happens at this stage, activation. There, is it going on? You guys can hear me, hello? Yeah,
No,
please.
Yes, I can hear you.
It returns the values once you activate it. It actually gets the data for you, right?
No, actually, activation still will not get to the data. That's what I discussed. See, what happens is here, we're actually dealing with the structures, right? Here, in the process of creating this views, for example, we tried with the attribute views here. So what happens is here, when we drag and drop our table here, what happens here? It only gets the structure, isn't it? First of all, it accesses the structures. Let's say here, you will show this is just a structure, right? So in this, the create deals with the structures only. Saving the whole structure will be an XML file or something is just saved. Activate means the actual object of the structure will be created, which means it is still an empty container. Yeah, you agree with me? It's not full container. When I say full container, is with the data. When I say empty container, it is just without data. But at this stage, it becomes full container. That means it goes and fetches the data. But once you once it serves its purpose, which is like in the reporting tool would be calling that object, or you are trying to preview that object, it will go and fetch the data, and after this immediately the next stage it just becomes empty container again, which means it is just a structure, but it is activated one, which means it is the object of that structure is created. Now the immediate question is where it is created. Does it create in your schema or where it is created? If it creates in your schema, that means everybody end up creating their modeling artifacts in their schemas. So I think SAP thought it is a little bit difficult to handle it, because to get to the schema structures, you have to go to the everybody's schemas. That's why it said better that I put it in one schema, or this one. I'm sorry. this is the system-defined schema. It will have all the activated objects, which means all the empty containers, which means all your modeling artifacts are going to be sitting down inside the repository, inside this schema. That's what I'm talking here. Is that okay? This is very important for you to understand, because the modeling technologies knows from the outside world, outside SAP, be it from the business objects or some other modeling technology, they always know that there is going to be only one place to go there to fetch the modeling artifacts. So they just have to come to this place to actually fetch the required modeling artifacts. From this place, the SAP HANA knows how to go inside into the database and get the data and then make it full, make the empty container into full container, and then send it to the reporting technology to serve the purpose. And once it sends the data, it is reporting technology's aspect, how it deals with the data, whether it keeps or not. But again, this BIC has just an empty container after serving the purpose. It is very important for you to understand this concept in the modeling if you want to become a modeler. So is that clear?
So does that mean, so for anything where it's in the BIC schema, that these are SAP already created objects, or does this mean that once the user has actually created the these objects, then they get saved to the SYS BIC schema?
Yeah, that's a good question. I think the second one, what you said, is exactly. See, in this, the user creates, isn't it? For example, Asma creates here, I create, I save, I activate. The moment I activate, the actual object is going to go and placed inside this. The moment you activate, technically what happens is there's going to be an object which is going to be, placed inside this schema. That means all these objects are respectively users are created. Even for us to go and access our own schema, our own object modeling or artifact, we have to go to this SYS BIC, but I'll show you just now. Filter it to SYS BIC to get to that. It's more easy. And then you just see you have this SYS BSC, and then you have all the column views. You see here, you can again filter it, for example, with your name. You might be having your own artifacts. For example, on my name, if I filter this, so I have all the my artifacts. You see, all these are the modeling artifacts that I have created and activated in the system. You got it? So this is the same thing. If you open this, you can actually see that structure. It is just a structure here. All these are empty containers for you. They will not have the data. They will never have a data. They will just go and fetch the data and give it to you as and when you require it. That's how the whole modeling process works. Remember, the modeling artifacts will never be with the data continuously. It will just be used to go and fetch it. It is like you make a box, you put all your required logic and make it ready to serve it. When it comes to serving the purpose, it will just go into the schema, because when you make it, you know that from which schema you drag and drop this table. It knows what kind of logic you implemented inside. It knows what kind of hierarchies you did it inside this. So it is already completely done it, created, saved and activated and kept. After the activation only it will go into this place. Which means it is ready to serve you. You got it, Asma?
Yeah.
Yeah. So that makes sense, right? Okay. So that is the fundamental point of this to understand. And then, which means the user, the same thing, whatever we talk here. But when we activate all our attribute views, analytical views, calculation views, which are going to see, we'll be seeing this analytical views onwards. We only just saw attribute view. That all these modeling artifacts are going to be created and kept inside the BIC under this column views. One more thing I want to remind right now again is that we cannot create modeling artifacts with the row tables. No. You remember this, right? The only way is the column has to be, the table has to be column-based table. In this case, yes, we can create modeling artifacts. I think we discussed why SAP did like this, isn't it? Because the row base is not good for analysis. We try to think about, conducting analysis when we actually do the modeling here. The ultimate purpose is we implement analytics, be it, trend analysis or forecast analysis or predictive analysis or sentiment analysis. You have so many analysis aspects. But for all analysis aspects, you require column tables for you to model. So that is why here, the interesting thing is, in here, it was named as column views. Inside the schema, inside the column views, you will find all the activated objects. If you're not finding, means you're still in the process of creation. You still did not activate it, you just saved it. Saving will be in something else. Activation is something else here. So here, remember, activation does not mean that the object is going to be with the data. No, it is just comes into an object form. Still, it is a structure, but it is finalized and it is just kept inside the PIC. That is the meaning. Okay, so and then we have the other type also, repository. These are the 2 and 3. I think 3 type of schemas. You have to be very familiar with this. The other is not necessary. So the second type of the schema that we have here is SYS underscore repo is a repository, which is whatever we create inside this is available inside. This is a superset of this. Everything it will have. Schema activated, inactivated. For example, here you see inactivated objects will not come into BIC. It is only activated. But here, inactivated objects means, I think now, when we create, when the process of while the process of creation, from here to here, let's say, still inactivated. The object is not activated, isn't it? So where does this object stays in the process of creation? Obviously here, in the repository underscore repo. This particular schema contains this. So everything it contains the package details. The package is something that the container of all your modeling artifacts, isn't it? The package is something that in here, the content, you have something called package, isn't it? You say it rightly, you have a package. Package is a container to keep all your modeling artifacts. That is what is a package. So that thing is also, all the things will have in the repository. And then any sys repo user must select privileges with a grant option on the data schema C, which means what? For the first time, whenever you create a schema, of course, the purpose of creating the schema is you would want to keep your database objects inside. Could be your procedures, your tables, the physical tables and all that. You would want to keep them inside your schema. But for the first time, you have to take a permission, which means you are asking from the sysrepo, please grant a permission for me to use all my objects inside the schema directly, which means unless you do this, we cannot use those objects. For the first time of your schema, whenever you create, you have to do this. For the first time, you have to do this. If you want to use the objects of the schema, use means what? Use means like this. When you create modeling, what happens? You are using it. You're actually connecting to that particular schema from here. Let's say you type your table name and then bring that table onto this data foundation node, or you just go here and then you simply drag and drop here and then put your table into this. That means you are using that. So if you want to use any of the object which is inside your schema, you have to first take the grant option from the repository, because the repository is the owner of the schema. Actually, you are actually trying to make this is the default thing that you have to do actually for every schema that you create for the first time. That's all. Just one time you have to do this. And the other third type that we have here is we have BI, which will have all the metadata of the created column views. and it also contains the variables, which we'll be seeing it. Because see, does the attribute view contains variables? No, it does not contain, I guess. We will see. If there are any variables, you will only see here. If you say here, it's just a hierarchy, there's nothing. So attribute views only contains hierarchies. It does not contain variables. Then where the variables will come? It will come going forward, because attribute view is the fundamental modeling artifact, the tiniest modeling artifact that we create in our building blocks. We're going to go on and complicate this going forward. We'll be having the cubes, multi-level cubes and all that. So also the time data. I think we have seen this. The time data exists inside the BI. Just now we have seen all the 4 tables of the Gregorian calendar. You can also see the fiscal tables also that I mentioned here. For example, when you get to the tool, you can just go there and check this also. You know, all these, by the way, all these slides I have kept it in URL, which I gave the access to Aruna and Kamran. Maybe the Faisal and Asma can get those URLs from them or from me. If you send me a test email to me, I can also forward that URL. So my email is this one anyway, I think, if you don't know. Because you need to have all this. You should be, you know, going through all these slides to understand more continuously, I mean, as and when you have time. So you send me an email to me so that I forward a link, URL link, where you have all these PPTs, all the details, everything. I kept it there. So PDFs, some of the PDFs from the SAP company itself, we have various PDFs also. I kept 4 PDFs also there, so that you can just download and, you know, use them for your purposes. So, and then it has also the schema mapping and then content mapping tables. So what is a schema mapping? Schema mapping is something that I will see. For the moment, you just, you know, leave it. I'll have to discuss all these for you to understand what is schema mapping. See here, you see schema mapping. This particular thing is also is going to be inside the SYS_BI. Then content mapping is also in the same thing. So I'll be showing. So SYS_BI contains all of these things, which are, you know, metadata of the columns, and then variables, input parameters, and then time data, schema mapping, and then content mapping things. So these are the 3 things. I think the statistics and access is not required for you, I mean, unless you are interested in the application development and, you know, as here system administrator point of view. So you can get these details also from my slides. So let's just move on to the next modeling artifact, which is analytical view. Is it okay for now?
Yes.
Okay. I will actually take a 5 minutes break and then we start. You want a break, or I think I continue because there's no time here, just it's already 9:06. No problem, right, if I continue for another half an hour? Okay. So what is analytical view right now? Aruna, no problem, right? Asma?
No, I have no problem. That's okay.
Yeah, no problem.
Great, okay. So let me just talk about this. Is very important modeling artifact, which is called analytical view. So let us see what it is. So in the process of learning, I think we saw, you know, how the modeling is being evolved, right? From ER modeling, I was trying to show you, you know, in my slides, how the ER modeling is done, and then how the multidimensional modeling, you know, can be done. In that, you remember we discussed about the star schemas. So here, yeah, it is just the HANA terminology. Star schema is nothing but your analytical view. That's it. So the only, because the tiniest multidimensional modeling artifact that we have, see, by analytical view, we are already entering into multidimensional modeling. Before that, we were in 2-dimensional modeling, which was attribute view, which is just a fundamental modeling artifact. But right now, we are entering into the multidimensional artifact, multidimensional modeling. So in the multidimensional modeling, again, the fundamental modeling artifact we have is a star schema. The tiniest in the inside the multi-dimensional modeling is star schema, which is, we know that there is going to be a fact table surrounded by the dimensions like this. I think just to remind, you have a fact table here in the center, and you also have dimensions. For example, 2, 3, 4, 5 dimensions also will be there. This is a dimension, and this is a dimension, and this is a dimension table. Okay. And then we have this is your star schema, right? This is nothing but your analytical view. But now we have to understand how to create this, and then step by step how to bring it into a workable form, a workable condition. Here, the end result would be, you remember what was the outcome here? I think if you remember, we end up having a cube, isn't it? To capture the cube, we do all the star schema process, isn't it? The cube is nothing but this. Do you remember?
Yeah, you showed that to us.
Exactly, I showed to you. So for example, this is a cube. How do you get this is, you require to go through this to capture all the information. Only then you can get to this cube. This is a cube here, but this cube is a central table. Once you have, associated, the fact table gets associated with all the dimensions and capture all the information, and then with the aggregated information also here, then this is nothing but a cube actually. The idea is to derive to this. This is again a relation, it is just in a table. So how do we do that in HANA? Something that we have to see right now. Okay, let me just go back to our, yes. So the fact table is surrounded by the dimensions, calculations, and restricted measures. See, the point is here, the dimension is here, nothing but your attribute. Okay, now I think it is clear. All these are attributes. That is why we created first dimensions, attribute views, because we go step by step. We go to the complex modeling artifact after this. This is a basic fundamental multi-dimensional artifact we are trying to create. And then from here, we move to complex modeling artifact also. To do this basic multi-dimensional artifact, you require the two-dimensional modeling artifact, which is dimension here itself. So this one is an attribute, this one is an attribute view, this one is an attribute view. So then what is a fact table? We will see what is a fact table. And then in SAP BW, we can also compare with info cubes or info sets. Anybody has experience with the BW?
I just started learning BW.
Yes,
So that's
sir.
really nice. Okay, Kamran has the knowledge. Yes, sir. So in the BW, you remember info cubes and info sets?
Yes, sir. Info cubes are basically the data is stored in SAP server in form of, BW server in form of info cube.
Yes, sir. So we can compare this analytical view with the info cube and info sets actually, because that is also a fundamental multi-dimensional artifact, info cube and info set. This analytical view can be compared. That's why I just try to put this so that you can relate with your experience if you had experience of creating this anyway. If not, it's okay, don't worry about this. And then analytical views are typically defined on at least one fact table that contains transactional data along with the other number of tables. See, the point is here, the first step is to be analytical view, you require one fact table. This is for sure, we have to have it. Without this, it cannot be qualified as an analytical view. So maybe you may not be having the dimensions. Maybe you have one dimension, 2, 3, 4, 5, so on and so forth. But at least one fact table is required. So then fact table is derived from where? Fact table is always derived from transactional data. Because the dimensions mostly are derived from the master data. These two are two different types of data, isn't it? So that is what something. So, and that is this point. We will see an example how we can, make this modeling artifact. And it will also have some other things such as aggregation. You have analytical views leverage the computing power of SAP HANA to calculate aggregates. For example, the number of bikes sold per year and the maximum power consumed per month. See, it's the same thing. You remember I was showing you an example there with the customer sales ID, the quantity, and the quantity can be an aggregation in our example. It's talking about this is of the same thing that we discussed. This one. You know this actually. After knowing this, you know how the analytical works. It is just a terminology. We're trying to say this cube and star schema is nothing but analytical view. Here, you see amount here. We have the amount, and we also have quantity also. I think quantity is not here in the upper. Where is the quantity here? Yeah, here. We have quantity and we have amount. So all these can be aggregated like this. The amount can be aggregated in terms of product, in terms of store ID, or in terms of sale ID. Anything. See, not sale ID, I'm sorry. In terms of time ID. So what is the product here? Three things are 1 minute. I have product, store, and customer ID, yes. Yes. Here, the amount can be, the moment you say amount here, amount of what? Amount of store you can map, amount of product you can map, amount of customer also you can map. You can actually aggregate it, store and customer combination, or product and store combination, and all this can be done easily, isn't it? This is a very beautiful concept. Otherwise, if you want to get to this from the basic tables before, developing this star schema, you can also get to this, but it is very difficult for you to write a query. It is a little bit complex actually to come to this point. But once you make this star schema and then create this cube, it becomes easy for you to derive these aggregates. That's what he's saying actually here. So analytical views are the main purpose for us to actually think about in terms of aggregating. So we see that aggregating data will happen inside the analytical views. So this is one of the fundamental reason why we create analytical views, because your analysis requires aggregation, right? So that is what here. And then it's specifically designed to execute star schema queries. That's okay. So how does it? It looks like this. For example, this is a cube, which is actually fact table here, surrounded by the dimensional tables. Here you have the dimension tables, product you have, then you have location, and then we will see this. So this is how the analytical view works. Let me just show you in the HANA Studio. In the HANA Studio, what we can do is we can actually say right click, and we have to go to our content folder, and then inside that we have a package, and then inside the package you could be having a sub package. Until that point you must go to actually to define your own analytical view artifact. So this is, you see here there is already a cube structure. Do you see that? This one is just plain. It's just a two-dimensional artifact. You can see two-dimensional planes in the picture. Is it visible? All these pictures are visible associated with this. Yeah, because I'm worried maybe the resolution is not good for you.
No, I can make it out.
Yeah. Okay. So this picture it shows two-dimensional, and then here this picture you see it is already a cube, which means this is the fundamental modeling artifact you are into it. The next one, you see the picture also says a little story about it. This is calculations. This is more complex on top of this. So let us just go to this analytical view, and then we say the name, AN underscore something. Here, there are no types, you see. There are no subtypes. Straightforward, we have only one type, which is analytical view. Unlike the attribute view, we try to have, for example, if we change this one to attribute view, obviously we have so many types. We have standard attribute view, we have time attribute view, we have derived, and then we can also copy from. But here, in the analytical view, there's nothing. Just a copy from. Copy from it works the same way. Copy from is nothing but if you want to take the existing attribute analytical view and then make changes, that you use copy from. If you go here, take the analytical view and then do the same way how the attribute view we explained. But except that there are no other ways. Just if you see that, it will just create. Yes, it looks like this. You know, your analytical view looks like this. I think this would be a little different from your attribute view. Attribute view was only data foundation and semantics, you remember? But right now, we will see something called star join. There's another data foundation, the star join. Here, you have the data foundation. And the next level, all these are the nodes. We have 3 nodes here for the analytical view, whereas for the attribute view, we only have the 2 nodes, data foundation and then semantics. But here, there's something called star join. We'll see how to work on this. Data foundation is something that you will have to go first here and then bring your transactional data, you know. You will have to actually drag and drop your transactional data here. And then once you drag and drop the transactional data, I think I have some example for you here. Yes. Let me close all of this so that we can have some space. So here, what we do is, the idea is like this, huh? We try to bring all the transactional tables here, be it 1, 2, or how many, a number of tables, but at the end of this process, this node will have only one view. So all these tables becomes one table, which means these tables, whatever you bring here, will be having the joins, right? And then you would not be taking all the field source, like I said here. In the modeling, it is always about filtering it, right? It is always about narrowing down until the requirement aspect fulfilled. So here, always the data foundation in analytical view, you remember, it is going to be a transactional table here. Maybe this example could be not very good example I have, but in the project COPA that we do, I have a very good example. You'll be developing very complex analytical views. So once we are into that. So right now, this example shows some purchase order and purchase details, which means the purchase order is connected with the details, like to arrive to a purchase information, which is a transaction information, which is probably daily based, if not hourly based, and then weekly based information will be fed. That is nothing but a transaction detail. So you'll have a, you know, company number, vendor, and all that for your transaction. I mean, let's say the quotation, quantity, currency, some information which is transaction-based information, which is changing quite often. So here, irrespective of the number of tables that you have, you may have 1, 2, 3. Obviously, you will have joins to get the relevant information, the connectedness. So you end up having the number of columns here, which will be coming up like one view here. So if you go up to the next node, the data foundation from this previous foundation will be held as one view here. So you're actually combining here in your data foundation part of the analytical view. All your transactions, for example, if it is only one transaction table, be it one transaction table, so that you don't have joins. In that one transaction tables, you try to select what are the required fields that you want, and then you try to see if you want to filter it. Filter is, I've shown you, like right click and apply filter, which means you're actually, let's say, if the company name, if you only want companies, out of 5 companies, you only want 2 companies, you can filter here. So it means you're chopping it off horizontally. And then if you don't select this, you are chopping it off vertically. So we do all horizontal chopping and vertical chopping, which means we omit the information, most of the information. We only focus on what we want the same way, but here transactional data always. So you bring your transactional table here. And then here, for example, in this example, I use the referential join with the same PO number to get to the, this particular transaction details, to understand PO status and currency, and then store location, plant, and so on and so forth, all this information. So whatever you have selected, for example, right now here the company, if I unselect this, the company, so the company is gone here, it's not there. If you want to select it, just select it. That means company is going into the output. You see the company is going into the output. So whatever you want, you select it, which is going to the output, which means always any node output will travel to the other node, upper node, always here, from down node to the upper node. It is always like this. Earlier in attribute view, we have the data foundation, it traveled to the semantics. Right now we have a data foundation, it will travel to the next node, which is a star join node. In there we again try to make, star schema, and then followed by, obviously, end of the star schema is going to be one table, which is a queue, will travel to this semantics node. So that's how it works. Right now, this is something that here we have to understand. There is some new concept called input parameters. We will talk about this. For the moment, you just see that there is a concept here, because we'll be creating so many input parameters in our project also. We'll talk about that. For the moment, you just understand how we can create analytical view, which is a star join. So once I move on to the star join node, I've got this data foundation view, basically, or you can call it table for the moment. It's not really a table. It looks like a table, obviously, with all the columns, associated columns here. These columns are the columns that you have chosen here. And here, this becomes your fact table. You will try to add your dimensions here by clicking here, or by just dragging and dropping. For example, the table you can drag and drop here. So that particular drag and drop table is going to be your master data tables, which are actually your attribute views here, if not the tables. Mostly attribute views you create to use it as a dimension. So you already changed the table such a way that whatever the necessary things you wanted, you made it as an attribute view. So that particular attribute view can be dragged and dropped like this, you see. It will just come. The same way you can do with any number of attribute views, because here the idea is fact table is being created in this node and has come to this place. So I require to add more dimensions here, 1, 2, 3, 4 dimensions based on the requirement. So that dimension obviously will have a connection with the transaction. I mean, otherwise we will not do this process, right? So we know that this particular transaction table is having a connection with this particular master data table that we are bringing in here. For example, here product. Right now I have a sales purchase details here, and then the purchase details table is like a fact table here, and then I bring the product dimension to this. And then I try to work on the join, what type of join I want. And again here, there's going to be always, the cardinality is going to be which way here. Mostly in practical situation, of course, here is 1, but in practical situation, here you see the cardinality. If you click this, you will see the join details like this, the cardinality. Mostly, this example is not very effective example. Mostly in the real-time scenarios, here there could be a, 1 to many. Many you will have here because the transactional table, 1 you will have because the master data table. For every product, you have, it would have been come from various clients. So 1 to many here you have. The many represents the transactions. So the one represents the master data table, which is the dimension. So in practical situations, in most of the real-time scenarios, you will have one too many here. That you'll be seeing, for example, in our COPA exercise that I'm targeting to create also, you will have one too many. So after this, in this process, it's again the same thing. What are the columns you want to select? Mostly if you want to unselect anything, you just have to drop down here. So click this one, so that what happens is you're actually unselecting this. And then in my case, probably I've selected everything here because I've filtered unnecessary things here itself, isn't it? In here itself, I've already filtered it. So I know that mostly the fact table is going to go the same way, except the dimension table. Obviously, we don't need some of the dimensions. We just, deselect here, and then we chop them off. And here, the interesting thing is you have so many things here. This is the attribute use. We have one column here, one folder here. All the attribute use you bring will come here. For example, right now I only have one attribute because this being a star schema, I can have 3, 4, 5 attributes also based on the requirement. And then I have these columns. This is the object that will be going to the next node, which is the semantics. So all the required columns that you are choosing here and here will be coming in here, And then you have something called calculated columns. We'll have to talk about that. You have something called restricted columns. We'll have to talk about that. Of course, input parameters also here and also coming up to this place. Here also you can create. That means what is input parameters? We will talk about that, of course. All these are the, extra technological aspects for you to help in your analysis, to conduct your analysis more smoother way. All these things will be helpful. We'll be talking about this. What is the calculated columns? So calculated columns basically are, assume that you would want to, derive a column from the, I think you remember we also have the calculated column in attribute views. Do you remember?
I know what calculated columns are. We combine two, three columns and make one column like.
Exactly, good. So actually we talk about calculated columns in attribute view itself, just for you to remind. I'll just quickly go there and show you. This is an attribute view, right? If I double click this, I open the attribute view. In there, if I go here, I see calculated column here. Even in the attribute views, we have a calculated column. See, the fundamental difference between, attribute view and analytical view, of course, you know the differences, but one of the main differences is attribute view will have only attributes, but whereas analytical view will have attributes and measures also, because we are in the multidimensional modeling here. This one is two-dimensional modeling. That's why these two, you have to remember that we will not have measures in attribute views at all. So the measures is some concept that is being introduced in the multidimensional modeling. The same attribute here becomes two types, either attribute or a measure. So you have to look at it in two different ways. So here, calculated columns, the way I wanted to say this right now is the calculated column that you have inside the analytical view. Sorry, sir, again?
No.
Sorry, sir, again, you wanted me to stop? Somebody's talking, sir, Faisal Sahab or Kamran? Somebody was talking something. Hello?
Yes, sir.
You're saying something to me?
No, sir.
Okay, sir. So actually, we will have the similar type of calculated columns here, the type that we have seen in the attribute views, but the scope is much bigger here because here you have not only attributes, you have measures also. So if you click new calculated column, it looks like this. Here you have the attribute or measure type, the column type is. That's something that you have to remember, that we are into multidimensional modeling. The fact that you see measure is nothing but a multidimensional model, because of course this is a star join, but whereas on the other hand, clearly, if I let me close this and then go to the attribute view, if you go here and then see this calculated column, you will not have attribute or measure here. You just have a data type, because it's already fixed that it is an attribute. You understand, sir? Because there is nothing called measure in your attribute views. Even though there could be measures fundamentally, but you do not call them. You just call them as attributes. All of them, every column is just an attribute in your two-dimensional modeling artifact, which is attribute view here. So do not get confused with the naming conventions here that HANA does it. So here, you just have to calculate a column, always presumingly it is just an attribute. That's why there's no way to mention here. It's just an attribute. Of course, it mentions the data type it is you want, what are the type it is, and what is the expression you would want to derive. Like, you use the previous columns and make new column. What kind of column you want to make, you give this. But whereas here, the scope is bigger. You will see that it is, the type is also a measure. You see? If you choose this, the dynamics will change. If you choose measure, that means it is a measure. But if you choose this one as an attribute, that means that column is going to be an. Essentially, you are actually creating a new column, which is called a new column. But since you are making some expressions, they are saying calculator, which means you are actually calculating from the previous columns and then deriving it as a new column. That's it. So I think it's the same concept what Aruna was telling, but the scope is bigger here. And they are used to create new output columns and calculate its value at runtime based on the result of an expression. You use the arithmetic expressions there. We can use functions, we can use string functions or miscellaneous functions or mathematical functions or anything. We can use input parameters, of course. I still have to discuss what is input parameter. It's going forward. The next slide is there. We can use, so many other things also. One example could be, you can actually calculate net revenue from the gross revenue. Gross revenue is an existing column in your, let's say, the transactional table, where you do not have a net revenue, but net revenue needs to be created with the help of calculated column by introducing a new column. So that would be one example. And the second is restricted column, which is very important. They say restricted. So what needs to be restricted? There's something that we cannot bring restriction in calculated columns. So let's see what it is. Restricted column is something that, you restrict the column based on the attribute. Here, when you do the calculations on your columns, you actually calculate on these columns only, right? You try to, make the average of this column or try to bring some relation expressions and calculate, some tax, some percentage, something, and then you try to calculate. But here restriction is something that you try to restrict by way of restricting an attribute here. So the restricted column is always going to be a measure.
Excuse me, sir.
But you are actually, please.
Sir, basically I have to go for 10 minutes. So if you will be...
No, I think in that case it is already 9:36. Better we end this class if everybody says, okay, I want to end this class, and then again we will see tomorrow. Is that okay, everybody?
Sir, will we get the server active tomorrow? Because until unless we will not do the practice, so everything is going just, very dry mode until we will not have any project objective and server activation. So will
Yeah, you should be getting it in the next, I think tomorrow mostly, if not tomorrow, the day after, because until that you try to get this one server credentials that you have from, I don't know, probably you can log on, because I want you to guys have server access when I start the project. It will not be like this. When I start the project, I'll be showing and you'll be doing the project as and when I talk. Only then it will be interesting for you. I know that.
Yes.
So I require that also. In the project cannot be like this. Now I'm talking about the concepts. The project is something that you will be doing while I'm saying. I say you create this dimension, you will be there, creating dimension, you will be activating it, you will be seeing the result, and then you will be making the fact table, all that step by step. Otherwise, I know it will not be a proper learning. I understand, sir. Come on, sir. So
Yeah.
I'll raise this issue again with the training guys. I'll make sure that you get that. All of you should get it. I also should get my own because right now what I'm showing you is my own, other sources server access, not
Yes.
from this training
If you get
mediation.
the
This is
server
something
access,
that,
the one I have, it's all blank. There's nothing in there. You have to create.
yeah, because you see in my folder, you see so much I've done. This is
Yes.
some other concrete training server access. You see the whole project. For example, in the COPA, if I open this, maybe it's not required for you. It'll look like, going forward, it'll be very complex. For example, it'll look like this. Your view could be looking like this. You'll be developing all this. You see this? Do you see this?
Yes. I
So it'll
cannot.
be like this actually. Yeah.
There is
Yes.
nothing in there. It's just empty. All the everything. There is nothing in there. It's just a basic thing, and that is what it is. We have to create everything.
Correct, correct. So we have to go step by step. So I cannot show like this one and then in the day one, We at least that's why it'll take 2 classes, at least, 4 hours to 5 hours probably to just create this. So I want all of you to have server access when I'm doing this project. This is a COPA project.
Sure,
I'll
sir.
talk to the again training guys. Yeah, okay, sir. So I think if all of you say, okay, now we can end this class because Kamran sir is leaving. I
Yeah.
think better we should end this class.
We can continue tomorrow. And actually, for now,
Please.
if everyone, if you all agree to that, we can make it on alternate days.
Sir
Yes,
told
okay.
we'll do alternate days once the project will start. Sir told yesterday that
No, unless you have any objection, because my objection is to, cover more things. Maybe, like last time I was on travel, right? Suddenly if some traveler comes, unnecessarily I would put, you guys into trouble. So I don't want that to happen. I want to cover more topics, at least, some half of the topics so that, what, the modeling at least, so that we can do it relaxedly. But unless you say right now, no, you have a problem, obviously it is alternative days. Please, it is your call.
No, I'm okay with that. If everybody, I mean, we all should be okay. If it's not that I
Let's
said
say
that.
tomorrow, yeah, tomorrow and maximum day after tomorrow we take it. And then from there we make it alternative days so that we can get to the project, I think. After tomorrow class, I think it is going to be a project unless I move on to the architecture based on the server availability. Otherwise, I still have to show the architecture. I'll go on to the architecture topic because I do not want to get into the project unless you guys have the server access individually, all of you. And then you guys have to connect to the server simultaneously when I log in here, when I start showing the things. Is it okay?
Yeah,
yes, sir.
okay.
So we have,
Sir, can I give you call or
no sir, in the evening sir, you call me in the evening sir. For you, I'll find out your information before evening, yeah. Let me just talk with that guy. I have to go to work now. So okay then, good evening everybody, good night, yeah, thank you.
okay,
Thank,
bye.
thank
Oh,
you.
thank you.
Thank you Asma and Aruna, Faisal and Kamran.
Thank you, sir.